Overview of my NodeRed flows. I do have a debug tab here, which I originally started with just to manually actuate everything with no other logic. So to turn it on or turn it off for the heaters, for the fan, and you can hear it click in the background here. Okay, so there's that. Then I made a production tab here. And the production tab was really designed towards the final flows for everything. So I've got a bunch of stuff at the top for temperature and humidity from the DHT sensor. I've got a section here for manual fan control. Then I've got a section here for reading the MQ sensors from the analog to digital sensor. Below that, I've got the light control, which can either be done manually or through MQTT. I've got a buzzer control, which can be on or off. Of course, that light can be on or off. And that's the overview of the flow. And then if we go into it, just to walk you through a little bit, here's the inject, and this is the main thing that starts the entire flow. It's just injecting a timestamp at every 1 second. Okay, so every 1 second, that's going to fire. It'll trigger this node. Okay, so the DHT22, which is using a physical pin number 31. Okay, so the timestamp triggers a read from the DHT, and when that read happens, and I can just show you here because it's running right now, if I go to my debug tab and I turn on this debug node, so this is the actual reading coming in from the sensor. Okay, so every second it's pulling in all this data, and I'm going to use message.payload for a lot of this stuff, and message.humidity to read the humidity. Okay, so there's that. Then I have to convert to Fahrenheit. So I go in here, and this is the conversion because the sensor reads in Celsius. So I do 5/3 of C plus 32. Okay, so I've converted to Fahrenheit, and I round it to 2 decimals. I set a global variable for temperature. Then I read in the humidity from message.humidity, and I set the global variable, and then I return those 2 payloads out the 2 different nodes. You can see 2 different outputs here for temperature and humidity. Then it goes to rate limit, so 1 message every 5 minutes. Of course, I can delay or rate limit according to these settings here. And then it goes out to MQTT, and the same with the humidity. Now, every time this fires, if we follow the flow, it comes down and it triggers a reading of the MQ4 sensor, which this is the node from the ADS sensor, right? So we can drag it out and configure it. I'll delete that, and I'll go in here. So the methane is MQ4. It's channel 0 on the sensor. I'm just telling it to read at 128 samples a second, even though I don't need that much. And the gain of 512, which is the appropriate one for this voltage range. Okay, and these are all similar except they're reading channel 1, right? And then the other ones read channel 2 and then channel 3. So each one of those triggers a function block, and the voltage is the message payload over 1,000 because that comes in as millivolts, and I convert it to volts. and then I calculate the parts per million, and this is a logarithmic function, and according to SparkFun, this is the formula to convert voltage to parts per million. I do use a verbose output to calculate the volts and the parts per million for a debug, and then I also set a global variable for methane. So here's this tab, and if I pull it out, okay, so let me clear this, and I'll turn that back off again. So this debug tab is reading the raw output and the converted output for everything, so the volts, the parts per million. So methane is calculating at 10, which is very low. So that's good. Alright, so then I rate limit and I send that out to the appropriate MQTT topic. Okay, so I read all 4 of those, and then we go into the fan controller. And this is the main node for running the fan. I've got these 3 are physical outputs to the GPIO. Okay, so this one is GPIO 23, digital output. Okay. I also keep track, I push out to MQTT, so the rest of the automation system knows what's going on. Okay, so there's that. And I do have a debug tab just in case I want to debug it. So the fan controller, all this code is posted up above. We've got the fan request for humidity, methane, hydrogen, CO, and LP. I'm just comparing the global variable for humidity against a set point and deciding what my request should be for each sensor input. Okay, so methane, if methane goes over 1,000, I will say go high speed. If it's over 850, medium, and 750, low. Hydrogen, similar thing, 2000, 19, 1800, and 1650. CO, 12, 9, 8, 7. And of course the last one is the off, and the 7. If it's less than 7, it turns off. If it's greater than 8, it will turn on, and that creates the hysteresis. So it doesn't hunt, it doesn't short cycle, anything like that. LP, 1000, 850, 750, 500. Then we get to this section where we just find the highest one. Okay, so first we make sure that we're not in manual fan control. If we are in manual fan control, then we just read that setting. If we're not in manual fan control, then we use math.max, and we find the highest of humidity, methane, hydrogen, CO, and LP. So if any of them require the fan to come on, it'll just pick the highest one and set accordingly. And the last portion is the fan speed. Okay, so if it's 0, the highest one is 0, then we don't do anything, and we set the 3 outputs to 1, which is actually turning everything off, and then a 4th output just to 0, and that goes back to the automation controller. And then if we need a fan speed of 1, which is the lowest, we put the first relay to 0 and the rest are turned off. And if we need a fan speed of 2, we're using the second relay only, and a fan speed of 3, third relay only. Okay, that's the fan controller. Then the light control, very simple, so we're reading MQTT. Or we got manual control, so we can just turn it on or off. And again, there will be a UI covering this. We have a very simple logic block. If it's on, we use 0. If it's off, we use 1. And that pushes out to two different things. We've got the physical light pin, GPIO 5 on pin 29. And then we also push through a simple logic block here just to convert the 0s to on and the 1 to off. And that goes out to MQTT. And the same basic thing is repeated here for the buzzer control. So we've got on or off. And we're also reading from MQTT if the state request changes. So it'll come in here. If the request was for on, we use 1. If it's off, we use 0. Okay, that goes to the physical I/O for GPIO 26 to actually activate the buzzer. And we've got another thing to convert it back into on or off, which feeds out here to MQTT. So we've got local control and we've got the ability to feed back into the full system.